Good morning, everybody. My name is Payas Agarwal, student of BTech 8th Sem Aeronautical Engineering at University Department, Rajasthan Technical University, Kota. Today, the topic of my presentation is Antimatter Rocket under the guidance of Sir K. Bhatti. So, let's start with the first slide. So, this is the index of my seminar. So, we'll start with the first topic, antimatter. Antimatter is the same as ordinary matter except that it has the opposite electric charge. For instance, an electron which has a negative charge has an antimatter partner known as positron. A positron is a particle with the same mass as an electron but a positive charge. Particles with no electric charge, like neutrons, are often their own antimatter partners, but researchers have yet to determine if mysterious tiny particles known as neutrinos, which are also neutral, are their own antiparticles. So my next slide is antimatter production. Antimatter is exceedingly rare and short-lived in nature. So it must be manufactured artificially in the Large Hadron Collider, which is the world's largest and highest energy partial collider. Today, it can only be produced in the number of nanograms per year. There is technology available to create antimatter through the use of high energy particles collider called atom smashers. So my next slide is on the subparts of antimatter production. The cost of antimatter. Considering the low production efficiency, it would need 25 million billion kilowatt hour to make one single gram. Next is some pathways to store antimatter. First is penetrating tray. Second, magnetic levitation. Third, dynamic fields. Fourth, stabilized molecular bound states. Coming to next slide, that is an antimatter rocket. An antimatter rocket is a proposed class of rockets that use antimatter as their power source. There are several designs that attempt to accomplish this goal. The advantage of this class of rocket is that a large fraction of the rest mass of matter or antimatter mixture may be converted to energy, allowing antimatter rockets to have a far higher energy density and specific impulse than any other proposed class of rocket. So in next slide, we see classification of antimatter rockets. Antimatter rockets can be divided into three types. First, those that directly use the products of antimatter annihilation for propulsion. Those that heat a working fluid which is then used for propulsion. Those that heat a working fluid to generate electricity for some form of electric spacecraft propulsion system. In next two slides, we are elaborating classification of antimatter rockets. Pure antimatter rocket, direct use of reaction products. Antiproton annihilation reactions produce charged and uncharged mesons in addition to gamma rays. The charged mesons can be channeled by a magnetic nozzle producing thrust. This type of antimatter rocket is a beam core configuration. It is not perfectly efficient. Energy is lost as the rest mass of the charged and uncharged mesons. Lost is the kinetic energy of the uncharged mesons, which can't be deflected or thrust, and lost is gamma rays. Antimatter heating of an exhaust fluid. Several methods for heating an exhaust fluid using the gamma rays produced by positron annihilation have been proposed. These methods resemble those proposed for nuclear thermal rockets. One proposed method is to use positron annihilation gamma rays to heat a solid engine core. Hydrogen gas is ducted through this core, heated and expelled from a rocket nozzle. A second proposed engine type uses positron annihilation within a solid lead pellet or within compressed xenon gas to produce a cloud of hot gas, which heats a surrounding layer of gaseous hydrogen. A third proposed engine type uses annihilation gamma rays to heat an ablative cell with the ablated material providing thrust. Antimatter power generation. The idea of using antimatter to power an electric space drive has also been proposed. These proposed designs are typically similar to those suggested for nuclear electric rockets. Second is antimatter annihilation are used to directly or indirectly heat a working fluid as in a nuclear thermal rocket, but the fluid is used to generate electricity, which is then used to power some form of electric space propulsion system. The resulting system shares Many of the characteristics of other electric propulsion proposals typically high specific impulse and low thrust. Coming to my next slide, we talk about types of antimatter rockets. There are a few rocket types that attempt to harness antimatter for spacecraft propulsion. First one is solid for antimatter, second gas for antimatter, right? Fourth one is beam for antimatter. And few other types of antimatter rockets are positron ablative, ion compressed antimatter nuclear, antimatter initiated microfusion. Coming to next slide, application of these topics are first astrophysics, second one transportation, third one medical science. Next slide, advantages. First, antimatter is 100% efficient. When antimatter comes in contact with metal, it annihilates and the whole mass is converted into energy. Second, specific impulse of antimatter is very high. The specific impulse could be greater than 1 crore seconds. Next slide, disadvantages. Problem with developing antimatter is that it does not exist naturally. Storing antimatter is very difficult. It requires special containments to store. Antimatter is the most expensive substance on earth, about $62.5 trillion a gram. Next slide. Future scope. The main use of antimatter is in research. There are two main streams of interest, the first being high energy physics. This involves building bigger and stronger colliders in order to ascertain the properties of fundamental particles. This is a rapidly booming field and antimatter is present both as a part of the beam and sometimes as part of debris. The other part of lower energy antimatter is when stochastic cooling is applied to give a control level beam. This can then be used in other experiments looking at the nature of antimatter or in other fields such as spectroscopy. The popular future uses of antimatter are generally unfeasible. Some include weapons, power, propulsion. However, these are generally science fiction stories rather than new century weapons. The main problem lies in the production of antimatter. The net energy of all the antimatter produced to date would be enough to light a standard light bulb for 3 seconds. However, if this obstacle could be overcome and suitable storage technologies acquired, there is little preventing the production of antimatter weapons at the very least. Next slide, conclusion. After analyzing the whole topic, it can be concluded that the antimatter propulsion, even though it is under development, but it will certainly bring revolutionary change in conventional propulsion system. Now, mankind can think about the journey beyond the galaxy. Scientists believe that the speed of a matter-antimatter powered spacecraft would allow man to go where no man has gone before in space. With the use of an antimatter engine, it is foreseeable that in the mid to distant future, relativistic manner, interplanetary and interstellar travel is technically feasible. One of the major hurdles to overcome will be the technology required to produce and store large masses of charged antimatter. While this has been accomplished for small quantities of antimatter, any new-term solution will require breakthrough technologies that are capable of storing many kilograms of positron or antiprotons. Next slide. Any query?
Yes, how would antimatter be used as rocket fuel?
Antimatter can be used as rocket fuel because mass in antimatter is converted into energy. Any further query?
No.
Thank you.